Okie dokie. Module number 5. As always, I have a picture for the week. Just because. All right, so this week is all about network-based attacks and the various things that you have to watch out for. First up is the interception. Not inception, interception. The first problem that we got to deal with is man in the middle, where you have two machines, two devices talking to one another, and a third device gets in the way and starts listening in the conversation. It can impersonate the two parties, so neither one knows that they're being intercepted because they're getting the message. It just so happens that along the way, it's getting copied. Unless you have some form of infrastructure in place to listen when there's a new device on the network, you don't really know that this is happening. Another man in the middle, but this one is more specific, man in the browser, affects specifically, as the name implies, the browser. So whereas man in the middle affects all traffic that is coming in and out of the two hosts, and we're listening to everything, man in the browser is specifically for everything browser. This could be something like an add-on or an extension that takes the information that's coming in to the browser and relaying it out. Again, things that we could manage by controlling what can be installed into a browser. But otherwise, if the user is free to install whatever they want, they could, in theory, install something that will be able to record everything that's coming in and out of the browser, even if the browser is going to encrypted sites. Because we're looking at the browser itself, we can see what's happening. We also have replay attacks. Replay attacks are kind of man in the middle. It's more of a variation. It will listen for traffic that's coming in and out. It'll take something like a token, like for example, when a user on a Windows box logs into a domain, a token is passed through the network. Well, that token can be recorded and then can be later replayed in order to get access to that service or that whatever that server has in order to log in as that legitimate user, and now they're in. This is one of those attacks that most happens within the internal network. So an attacker has made their way in, and now they can see what's happening inside. Hopefully you have some form of sensors on the network to detect before something like this happens. But they don't necessarily need to have, like, especially when it comes to things like Windows domains, they don't need to know the password. They just need to have the hash in order to get in. But pretty fun stuff when you're the one doing the attack. Not so much fun when you're the one being attacked. Another set of network-based attacks are the poisons, with the first one being the good old-fashioned ARP poison. This essentially floods the ARP tables and says, hey, if you want to go to a specific address, it's actually this MAC address. With enough packets flowing through the network, the ARP tables on all the devices will get modified, and then they'll start talking the way that the attacker wants. In this case, for example, This attacker at 0.3 with this MAC address flooded the network and said, oh, if you want to talk to .7, it's this MAC address. And if you want to talk to .1, it's this MAC address. So now these two machines think they're communicating to each other, but they're actually relaying all their packets right into the attacker. Since this is ARP, ARP is a v4, IPv4 protocol, and it is local since we're only talking ARP, so it can't actually talk out to the world. So if somebody tells you that they're trying to do an ARP attack or an ARP poison on you and they're coming from the outside, well, they're totally lying because there's no way to do that. You have to be within the network in order to do ARP poison. On the other hand, DNS can be affected from the outside. If there's a vulnerability in your DNS server and it is exploited, then it is possible to modify DNS records and cause entire networks to go to the places that they should not go. It is important to make sure critical infrastructure like DNS servers are protected, are secured, and don't accept new records without those being verified by something like DNSSEC. Local users in any operating system that connects to a network has a host file that, for example, if it's any of the Unix, it'll be in /etc/host, or if it's a Windows type, you'll find it within the Windows folder. It's kind of buried. The Windows folder inside the System32 folder, because this is how old this host file has been around. Inside of drivers folder, inside of Etsy, and then you'll find the host file. Every OS has these host files. If that gets modified, the host will look at actually, a little backtrack. Every device that connects to a network uses this host file. So if it gets modified, it will look at the host file first before asking a DNS server. So as endpoint devices, you need to make sure that host files don't get modified, and also at the DNS server, make sure that it is secured and it is difficult to compromise them. Because again, if an attacker is able to modify records in the DNS server, then that just blows security out the door, because a legitimate server is issuing out the wrong IP address to services or to websites, and that just causes mayhem because it looks legitimate. So how do you detect that other than making sure that the system is as secure as possible? Another set of network-based attacks is privilege escalation. This keeps harping back to that least privilege principle of every user should only have the rights to do what they need and nothing more. Because if they're able to get higher privilege levels, they can do worse things. For example, if you look at this chart for the Windows side, if everybody is an administrator, then they are just one step away from full control as NT authority. If they don't need that type of access, then they don't need to be there. What attackers do is do everything they can to make their way up to be fully in control of the system so that they can do anything and everything. You don't want that. You want to restrict users to only do what they need to do and nothing more. Because it's never a if, it's always a when. And it may not even be a sneaky program. It could be social engineering that got a user to do the wrong thing and escalate their privileges, and now the attacker can do anything and everything to them. Speaking of servers from earlier, servers are all prone to denial of service attacks. I used to do this in the pre-pandemic days when I would do career days with elementary school kids. I would pick one kid from the crowd or volunteer. I would have that student stand in front of the class, and I would tell the rest of the class that they need to tell this one student 3 sentences, and they all need to talk at the same time. And then I'll count down, and then they'll all say their 3 sentences. And if you can imagine a room full of kids, they, for whatever reason, they decide they need to yell. So they all yell, a classroom of kids yell all at the same time. And this poor little kid is just standing there taking it all. And then I ask him after the madness settled, ask him what did he hear, and the kids just tend to say noise, nothing. And it's true. I mean, if you're standing where the kid is, all you hear is noise as these kids are trying to yell on top of one of each other to get their sentences heard. But the poor recipient just can't. Yeah. That is a perfect example of a denial of service attack from the point of view of the server. So many requests coming in at once that they just can't handle the traffic. And it's all bogus traffic. It's not really real requests, but it's enough to overwhelm the service so it can't respond to legitimate requests. So it looks like the system is down. It's not really. It's overwhelmed. This is anything that's DOS is all annoyances. And then you have a few more within this realm. For example, you have the distributed denial of service that uses hundreds, if not thousands, of devices to flood a target. You have the DNS amplification, where flood is redirected by other publicly accessible DNS servers. You have a SYN flood, which is what this picture shows, where you have SYN packets hitting a server until it runs out of resources to respond. Again, it's not necessarily taking the system down in the sense of it crashed, although it is possible. Most of the time, it's just the service has an overwhelming amount of requests that are not real, and it's trying to process through them all. The system itself is up. It's just not handling legitimate requests because it's busy with this wave. Now, we're going to put our focus, especially in our lab, to the web server application. Web attacks are one of the most prevalent of attacks, with one of these actually being the top issue for the web, as determined by OWASP, who handles this kind of stuff. This is a picture of the cross-site scripting, taking advantage of web applications that accept user input without validating before presenting it back to the user. This is where attackers can trick a valid website into feeding malicious script to a web browser, which will execute it. So the target is the user's browser, not the server where the site is coming from. There's also cross-site request forgery, an attack that uses the browser settings to impersonate the user by tricking the user who's already authenticated on a website to load another web page. This new page will inherit the identity and privilege of the victim to perform whatever undesired function on the attacker's behalf. So it looks like it's coming from that one user, the victim user, not really the attacker. These fall under the number 7 most common attacks on the web. The number 1 is SQL injection, otherwise known as SQLi. This attack inserts statements to manipulate a database server. SQLi tends to introduce malicious commands for the server to run. And like I said, you'll be doing a lot of this in the lab. Here are some examples of SQLi and what they result. You will be doing a whole lot of this in the lab, but because we use data, because the databases are so useful and they're normally connected to a web service, like a site, for example, do you really think that all people who have an Amazon account are really saved in a single file? That would be horrible to read and write. But a database is so much easier, more efficient to read and write many times at once. Well, if that database isn't properly configured and properly secured, it is a perfect ground of attacks. And because a lot of people do not secure these properly, it becomes the number one attack through the web. There are also other attacks like hijacking, taking a session by stealing a session token. There's URL hijacking. Instead of google.com, it'll be Google with an extra G or an O as a zero. It is also possible to hijack a domain by changing the domain pointer, or clickjacking, tricking a user to click on a link that is something else than what it seems to be. Web servers, along with any other service really, is, if it's not written correctly, it can be prone to buffer overflow, where too much data was given into that input. So let's say we make a web form and it's supposed to, it has a place for first name, last name, and age. Well, if we don't properly sanitize our input and say age should not be more than 2 digits, and so somebody notices that, oh, this takes more than 2 digits. So let me add something like, show me the password file in Linux, cat etsy/passwd. If the site isn't properly configured, it'll take that extra data and process it and then show the contents of the file. You don't want that. That is buffer overflow. You don't want that kind of stuff. You want to be able to take whatever input is coming in and properly work it, rather than just take whatever and let's see what happens. That's how things like buffer overflow can happen at a very basic level. Because the Security Plus exam doesn't expect you to be able to see buffer overflow by looking at code. That's more of CYSA and Pentest Plus. Here, it's just you have the understanding of what a buffer overflow is, and that's pretty much it. Browsers are primary targets because we're using browsers a lot. Just like when the pandemic struck and everybody started using Zoom, and all of a sudden these Zoom vulnerabilities started showing up. Well, that's because Zoom's popularity rose. So same with browsers, the popularity of browsers has gone up, so there are more vulnerabilities. Also note that there are really 3 browsers now. There's the Chromium, there's Firefox, and there's Safari. These 3 have their own engines, and everybody else comes from them, with Chromium having the majority share of the browsers right now. These 3 programs become targets, become things that we need to watch over. because it is possible for our users with the right permissions to install extensions that may do things that they shouldn't, or install plugins that will do things that shouldn't, or add-ons depending on the vocabulary that the browser has. Now here's a add-on. So for example, an extension could be written in JavaScript that has higher privileges than it should. So it could download selective links on a web page. A plugin could do things like read a PDF or play a video or an audio file, and that could be infected. Or an add-on, like a dictionary or a language pack, that again will add functionality that could make the browser vulnerable and cause you some pretty big headaches. Questions? Okay.